All right, so are you ready to jump back into more AWS exam prep?
Let's do it.
Think of this deep dive as like getting in a few practice rounds before the big game, like warming up those brain muscles and really getting ready to crush it on those AWS exams.
I like it. Yeah. And, we'll be breaking down these concepts in a way that even if you're just kind of getting your feet wet with AWS, you'll still walk away feeling like a total cloud ninja.
All right, let's jump into question 49. Let's see. Companies are running multi-tier e-commerce web applications in the AWS cloud. The application runs on Amazon EC2 instances with an Amazon RDS MySQL multi-AZDB instance. Amazon RDS is configured with the latest generation instance with 2,000 gigabytes of storage in Amazon EBS general purpose SSD volume. The database performance impacts the application during periods of high demand. After analyzing the logs in Amazon CloudWatch logs, a database administrator finds that the application performance always degrades when the number of reads and writes is higher than 6,000. What should the solutions architect do to improve application performance? So picture this. It's like Black Friday or Cyber Monday, and your e-commerce site is getting absolutely slammed with traffic.
Yeah.
Shoppers are adding items to their carts like crazy, but the database is struggling to keep up.
Right. Totally.
What's the solution here? I mean, it's clear that we've got a performance bottleneck, but how do we eliminate it?
Well, like you said, the database is clearly the bottleneck here, right? It's just getting overwhelmed with all those read and write operations.
Yeah.
So, it's like trying to shove a whole crowd of people through a single revolving door.
Right.
Not going to work very well.
Exactly.
The key here is to increase those IOPS, which is input-output operations per second.
Ah, IOPS. Okay.
Yeah, you can kind of think of it as the speed at which your database can, read and write data.
Okay.
And in this case, what we need to do is swap out that general purpose SSD volume for something a little more powerful, a provisioned IOKIA SSD volume.
Got it. So it's like upgrading from dial-up to broadband for your database?
Exactly.
But why provisioned IOPS? What makes it stand out for this particular problem?
Yeah, so provisioned IOPS gives you that granular control over your IOPS.
Yeah.
You get to choose exactly how many IOPS you need, which ensures that your database can handle those, those peak traffic periods without any issues.
Okay, that makes sense.
It's all about giving your database that dedicated performance it needs to keep everything running smoothly, even when things get a little crazy.
All right, so question 50. Let's take this global, shall we?
All right, bring it on.
A company recently expanded globally and wants to make its application accessible to users in those geographic locations. The application is deployed on Amazon EC2 instances behind an application load balancer in an auto-scaling group. The company needs the ability to shift traffic from resources in one region to another. What should a solutions architect recommend? All right, so imagine you're, a global e-commerce giant, right? You've got users all over the world trying to access your site, but you want to make sure that no matter where they are, they're getting that lightning fast, browsing experience.
Right, low latency, that's the key.
Low latency, exactly.
You want people waiting around for pages to load.
So what's the trick here? How do we achieve that global low latency magic?
Well, in this case, we need to bring in Amazon Route 53 and set up what's called a geo-proximity routing policy.
Geo-proximity routing.
Yeah, it does pretty much what it says on the tin.
Okay, so it's basically directing traffic to the nearest server, right?
Right, so it's like having a GPS for your website.
Like
automatically sending those users to the closest server to ensure the fastest possible page load times.
Yeah, awesome. All right, so moving from conquering latency to handling a potential traffic tsunami, question 51.
Okay.
A company is hosting an election reporting website on AWS for users around the world. The website uses Amazon EC2 instances for the web and application tiers and auto-scaling groups with application load balancers. The database tier uses an Amazon RDS for MySQL database. The website is updated with the election results once an hour and has historically observed hundreds of users accessing the reports. The company is expecting a significant increase in demand because of upcoming elections in different countries. A solutions architect must provide the website the ability to handle additional demand while minimizing the need for additional EC2 instances. So it's election night.
Yeah.
And everyone is glued to their screens waiting for those results to come in.
Right, high traffic time.
But we want to make sure our website can handle that surge in traffic without having to, spend a fortune on extra servers.
Yeah, nobody wants to go broke just because people are checking the election results.
Exactly. So what's the strategy here? How do How do we scale without breaking the bank?
So we can avoid spinning up a bunch of new EC2 instances by strategically using Amazon CloudFront to cache the website content.
Yeah.
Think of CloudFront as like a network of servers spread across the globe, all holding copies of your website content.
Okay.
So when someone requests a page, CloudFront serves it up from the closest server, minimizing latency and reducing the load on those origin servers.
So, I've always been a little fuzzy on caching. So can you kind of break it down for me, like how CloudFront actually works in this situation?
Yeah. So, CloudFront is AWS's content delivery network, or CDN.
Okay.
And basically it has all these servers, right, all over the world.
Right.
And these servers store copies of your website content.
Okay.
So when someone tries to access your site, CloudFront checks to see if it has a cached copy nearby.
Got it.
And if it does,
Yeah.
it serves it up from that nearby location, which reduces the load on your origin servers and makes everything run a lot faster.
So it was like having a network of strategically placed supply depots, making sure those resources are always available where they're needed.
Exactly.
Okay. Question 52 takes us into the world of IAM policies.
All right.
Always a fun time.
Yeah, it can be a little tricky.
A company has implemented one of its microservices on AWS Lambda that accesses a DynamoDB table named Books. A solutions architect is designing an IAM policy to be attached to the Lambda function's IAM role, giving it access to put, update, and delete items in the Books table. The IAM policy must prevent the function from performing any other actions on the Books table or any other. Which IAM policy would fulfill these needs to provide the least privilege access? Okay, so we need to make sure this Lambda function has just enough access to do its job, but no more.
Right, that's that principle of least privilege in action.
Principle of least privilege. Yep, it's like giving some of the keys to a specific room in your house, but not the entire house.
Exactly.
So how do we translate that principle into an actual IAM policy?
Well, we need to craft a policy that gives that Lambda function permission to perform those specific actions, put, update, and delete items on the Books table.
Right.
And then we need to explicitly deny any other actions on that table and on any other table.
So it's like saying you can go into this room and do these specific things, but that's it.
Right.
No wandering off and scooping around.
Exactly. Keep it locked down.
All right. Question 53 is all about containers, and I always feel like those are kind of like those Russian nesting dolls.
Yeah, they can get a little complex.
Layers within layers. So a company is building applications in containers. The company wants to migrate its on-premises development and operation services from its on-premises data center to AWS. Management states that production systems must be cloud agnostic and use the same configuration and administration tools across production systems. A solutions architect needs to design a managed solution that will be aligned to open source software. Which solution meets these requirements? So we need a service that can manage those containers, but also keeps things portable and flexible.
Yeah, because nobody wants to get locked into a specific cloud provider.
Exactly.
So in this case, the solution that fits the bill is Amazon EKS, that's Elastic Kubernetes Service.
EKS. Okay.
Yeah, and Kubernetes is that industry standard for managing containers.
I got to be honest, Kubernetes always sounds a bit intimidating to me.
It can be, but it's really not that bad once you get the hang of it.
Okay.
Think of Kubernetes like an air traffic controller for your containers. It manages all those containers, makes sure they're talking to each other properly, and keeps everything running smoothly.
Got it. So it's like the orchestra conductor for your containerized symphony.
Exactly.
Okay, but how does that cloud agnostic requirement fit in? How does EKS help with that?
Well, one of the cool things about Kubernetes is that it's designed to work across different cloud providers and even on-premises environments.
Okay.
So if this company ever needs to move their containers to a different cloud or back to their own data center, they can do so without any major headaches.
So it's like having a universal travel adapter for your containers, so they can plug in anywhere.
Exactly. Plug and play, container style.
I love it. All right. On to question 54. And this one is about security, always a top-of-mind topic.
Yeah, for sure.
So, a company has recently updated its internal security standards. The company must now ensure all Amazon S3 buckets and EBS volumes are encrypted with keys created and periodically rotated by internal security specialists. The company is looking for a native software-based AWS service to accomplish this goal. What should a solutions architect recommend as a solution? Okay, so encryption and key management, it can sometimes feel like navigating a minefield.
Yeah, there's a lot to keep track of.
So how do we keep those keys safe, but also make sure they're regularly updated?
Well, AWS Secrets Manager, specifically using custom managed keys or CMKs, is our go-to solution for this.
Secrets management.
Yeah, it's like a super secure vault for all your most sensitive information.
Okay. And what kinds of things would go in this vault?
So you put things like encryption keys in there, right?
Yeah.
Database credentials, API keys, anything that you want to keep really locked down.
Right.
And Secrets Manager lets you do things like schedule automatic key rotation.
Oh, that's nice.
So those keys are regularly refreshed, making it even harder for anyone to, get their hands on them.
So it's like having a team of security guards who not only guard the vault, but also change the locks regularly.
Exactly. Stay ahead of the game.
Okay, on to a topic that's music to my ears, cost optimization. Question 55. A company wants to use Amazon S3 for a secondary copy of its on-premises data set. The company would rarely need to access this copy. Storage costs should be minimal. What can you do? So infrequently accessed data, minimal cost. Those are key clues for selecting the right S3 storage class.
Right. S3 has a storage class for pretty much any situation you can imagine.
Exactly.
So in this case, what we want is S3 one zone infrequent access, also known as S3 one zone IA.
S3 one zone IA. Okay.
Yeah. It's designed specifically for data that you don't access very often, but still need to keep safe and sound.
Okay.
And that one zone part means that your data is only stored in a single availability zone, which keeps those costs down even further.
Got it. So we're trading a little bit of redundancy for some significant cost savings. Okay. Question 56 takes us into the realm of disaster recovery planning.
Okay. Always good to be prepared.
A company's application is running on Amazon EC2 instances in a single region. In the event of a disaster, a solutions architect needs to ensure that the resources can be deployed to a second region. Which combination of actions should the solutions architect take to accomplish this? Select 2. All right, so it's the ultimate what-if scenario.
Yeah.
What happens if an entire AWS region goes down? How do we make sure this application can be brought back to life in a different region?
Yeah, you got to have that backup plan ready to go.
Exactly. So what are those key actions we need to take?
Well, we need to think about how to replicate those critical resources in a secondary region.
Okay.
So first off, we need to launch EC2 instances from an AMI in that new region. So we're basically creating a copy of our server configuration.
Got it. So AMIs are like those blueprints for your servers.
Exactly.
Okay, so we've got the server situation handled.
Yeah.
But what about the data itself? How do we replicate that?
All right, so we also need to copy those EBS volumes, the stored volumes, from Amazon S3 and use that to launch a new EC2 instance in that destination region.
Okay, so why copy them to S3 first?
So S3 is super durable and cost-effective.
Yeah.
So it's like our offsite backup for our data.
Right.
By storing the EBS snapshots in S3, you've got a geographically redundant copy that can be easily restored, which is a best practice for disaster recovery.
So it's like having a spare tire in your trunk, just in case.
Exactly. You got to be prepared.
Okay, let's move on to question 57. And this one is about proactive security monitoring.
All right. Keeping an eye on those threats.
A company uses AWS to run all components of its 3-tier application. The company wants to automatically detect any potential security breaches within the environment. The company wants to track any findings and notify administrators if a potential breach occurs. Which solution meets these requirements? So we need a system that's always on guard, like a vigilant security guard, constantly scanning for any suspicious activity.
Right. We want to be able to spot those threats before they become problems.
Exactly. So what AWS services can we use to create this proactive security system?
Well, we can use a combination of AWS Inspector and Amazon EventBridge to create that kind of automated security system.
Okay, Inspector and EventBridge. I like those names.
Yeah, they're the dynamic duo.
So how do they work together? Like, what does each one bring to the table?
Okay, so think of AWS Inspector as like a detective, right?
Okay.
It's constantly patrolling your AWS environment, looking for any signs of trouble.
Okay.
It scans your EC2 instances, your container images, and other resources looking for vulnerabilities.
So it's like a security audit that runs continuously.
Exactly, yeah.
Okay, so Inspector finds the clues. What about EventBridge? What does it do?
All right, so EventBridge is like the communication hub, right? It receives those findings from Inspector.
Right.
And then based on predefined rules, it triggers those alerts.
So it's like the alarm system that goes off if Inspector finds something suspicious. Okay, so a real-time security alert system, that's pretty cool.
Yeah, you got to stay ahead of the game.
Okay, question 58 is about taking those security measures to the next level by encrypting backups.
All right.
So a company currently operates a web application backed by an Amazon RDS MySQL database. It has automated backups that are run daily and are not encrypted. A security audit requires future backups to be encrypted and unencrypted backups to be destroyed. The company will make at least one encrypted backup before destroying the old backups. What should be done to enable encryption for future backups?
Okay, so security audits can be a little, nerve-wracking.
Yeah, you gotta make sure you're dotting all your I's and crossing all your T's.
Exactly, especially when it comes to protecting sensitive data. So how do we transition to encrypted backups without losing any data?
Well, we need to take a snapshot of the database, right? Just to capture its current state before we start making changes.
Okay, so it's like taking a picture of the database before we start rearranging the furniture.
Exactly, yeah.
Okay, what's next? All right, so once we have that snapshot, we create an encrypted copy of it.
Okay, so now we have two snapshots, one unencrypted and one encrypted.
Okay. And then we restore the database from that encrypted snapshot, which creates a new encrypted RDS instance.
Got it. So we're essentially swapping out the old database with a new, more secure one.
Exactly. And from that point on, all new backups will be encrypted automatically.
Awesome. So what happens to those old unencrypted backups?
Once we've confirmed that the new database is up and running smoothly, we can safely delete those old unencrypted backups.
So we're complying with that security audit and making sure that no sensitive data is left exposed.
Right. It's like shredding those old documents that you don't need anymore.
Okay, on to question 59, which is about sharing data securely.
All right. Collaboration without compromise.
A company needs to share an Amazon S3 bucket with an external vendor. The bucket owner must be able to access all objects. What action should be taken to share the S3 bucket? So we need to give that vendor access to the bucket, but we also want to make sure the owner retains full control.
Yeah, you want to maintain that oversight.
So what's the best way to strike that balance?
We can do that by creating a bucket policy.
Okay, a bucket policy, so like a set of rules for that S3 bucket.
Right. It's like setting the ground rules for how that external vendor can interact with the bucket.
Okay. And what kind of rules would we include in this policy?
So we want to allow the vendor to upload objects to the bucket,
Right.
but we also want to make sure that they grant the bucket owner full control over those uploaded objects.
Got it. So it's like having a shared Dropbox folder,
Yeah.
but with some very specific permissions in place.
Exactly.
All right. On to question 60, keeping those applications running smoothly. A team has an application that detects new objects being uploaded into an Amazon S3 bucket. The uploads trigger an AWS Lambda function to write object metadata into an Amazon DynamoDB table with an Amazon RDS for PostgreSQL database. What action should the team take to ensure high availability?
Yeah.
So we've got this event-driven system,
Right.
but we want to make sure it can handle those events even if there's a hiccup somewhere along the way.
Yeah, we don't want any single point of failure.
Exactly. So what's the potential weak link in this architecture, and how do we address it?
So the weak link here is that RDS for PostgreSQL database.
Yeah.
DynamoDB is already highly available, right?
Yeah.
But that RDS instance is it's a potential single point of failure because it's only in one availability zone.
Okay, so if that one availability zone goes down, the whole system could come crashing down.
Exactly, and we don't want that.
Definitely not.
So what we need to do is enable multi-AZ for that RDS database.
Okay, multi-AZ, so that creates a standby copy of the database in a different availability zone.
Right, so if the primary database goes down, that standby copy can take over seamlessly.
So it's like having a backup generator that kicks in if the power goes out.
Exactly.
Awesome. All right. Question 62. Migrating those legacy systems, always a fun challenge.
Yeah, sometimes those old systems can be a bit stubborn.
A company uses a legacy on-premises analytics application that operates on gigabytes of CSV files and represents months of data. The legacy application cannot handle the growing size of CSV files. New CSV files are added daily from various data sources to a central on-premises storage location. The company wants to continue to support a legacy application while users learn AWS analytical services. To achieve this, a solutions architect wants to maintain two synchronized copies of all the CSV files on-premises and also in Amazon S3. What solution should be offered by the solutions architect? So we need to bridge the gap between the old and the new, keep those files in sync.
Right, we want to keep those legacy systems humming along while we transition to the cloud.
Exactly. So what's the solution here? How do we make this happen?
An on-premises file gateway is the perfect solution in this scenario.
A file gateway, okay.
Yeah, think of it like a secret tunnel between your on-premises world and the AWS cloud.
Okay.
From the legacy application's perspective, it's still talking to a regular file server.
Right.
But behind the scenes, that file gateway is busy replicating those CSV files to Amazon S3.
Got it. So the legacy application doesn't even realize it's interacting with the cloud.
Exactly. Seamless transition.
Okay, on to a topic that nobody enjoys, but everyone has to deal with unexpected cost increases.
Yeah, nobody likes seeing a bigger bill than they expected.
A company observes an increase in Amazon EC2 costs in its most recent bill. The billing team notices unwanted vertical scaling of instance types for a couple of EC2 instances. A solutions architect needs to create a graph comparing the 2 months of EC2 costs and perform an in-depth analysis to identify the root cause of the vertical scaling. How should the solutions architect generate information with the least operational overhead?
So I need to play detective, right? Figure out what's causing those costs to go up and how to fix it.
Right. We want to make sure we're not overspending on EC2 instances.
Exactly. So what's the most efficient way to investigate this cost mystery?
Well, the AWS Billing and Cost Management Dashboard is our best friend in this situation.
Okay, so no more manually combing through spreadsheets and trying to decipher cryptic billing reports.
Wait, the dashboard makes it really easy to see what's going on with your spending.
Okay, great.
It lets you generate detailed cost reports, break down costs by service.
Right.
And most importantly, in this case, you can create graphs that compare costs over different time periods. Awesome. So the solutions architect can easily see those cost trends and figure out what's causing those spikes.
Exactly.
Okay, on to question 64, handling a flood of events.
All right, event-driven architecture.
A development team is creating an event-based application that uses AWS Lambda functions. Events will be generated when files are added to an Amazon S3 bucket. The development team currently has Amazon S3 notification service configured as the event target from Amazon S3. What should a solutions architect do to process the events from Amazon S3 in a scalable way? So we've got these events streaming in, and we want to make sure our system can handle them without getting overwhelmed.
Right, we don't want those Lambda functions getting overloaded.
So what's the key to building a scalable event-driven system?
So the key is to introduce a message queue, right?
Yeah.
Specifically, we should create an SNS subscription that sends those S3 events to an SQS queue.
Okay, so SNS and SQS, those are starting to blur together a bit. Can you remind me what those services are and how they play together?
Yeah, so SNS, Simple Notification Service, it's our message broadcaster, like it fans out messages to multiple subscribers.
Okay.
SQS, Simple Queue Service.
Yeah.
It's our message holder. It sits between those event producers and consumers, making sure that no messages get lost or dropped.
Okay, so S3 sends events to SNS, and then SNS sends those events to an SQS queue.
Exact.
Got it. And why is that queuing mechanism so important for scalability?
So it's like a pressure release valve for your system, right? It allows your system to handle those sudden bursts of events without getting bogged down.
Right.
It's like a waiting room for events.
Okay.
So if your Lambda functions are busy processing other tasks,
Yeah.
SQS holds on to those incoming events until the Lambda functions are ready to deal with them.
So instead of those Lambda functions getting slammed with events, they can process them at their own pace.
Exactly.
Okay, on to question 65. And this one involves a truly massive amount of data, 30 terabytes per day.
Wow, that's a lot of data.
A company hosts more than 300 global websites and applications. The company requires a platform to analyze more than 30 terabytes of clickstream data each day. What should a solutions architect do to transmit and process the clickstream data?
Okay, so we need to move and process all that information efficiently.
Right, we need a data pipeline that can handle that kind of volume.
What's the winning combination of AWS services for this data deluge?
Right, so we're going to start with Amazon CloudFront to cache that data closer to the users.
Okay, so CloudFront is absorbing some of that traffic and reducing the amount of data that needs to be transmitted.
Exactly.
Okay.
Then we'll use Amazon S3 as our central storage repository, our data lake.
S3, that makes sense.
Yeah, it's perfect for storing massive amounts of data.
Okay, so CloudFront caches the data, S3 stores it, but we still need to process it, right? How do we do that?
We'll use AWS Lambda functions to process that data.
Okay.
Lambda can easily handle those large volumes of data.
Right.
And it can do it all serverlessly. So CloudFront for caching, S3 for storage, and Lambda for processing the perfect data pipeline for those massive data sets.
Exactly.
Okay, question 66 takes us into the world of serverless architectures.
All right, serverless is the future.
A solutions architect is designing a workload that will store hourly energy consumption by business tenants in a building. The sensors will feed a database through HTTP requests that will add up usage for each tenant. The solutions architect must use managed services when possible. The workload will receive more features in the future as the solutions architect adds independent components. Which solution will meet these requirements with the least operational overhead? So we're building a system that can handle those energy consumption readings from those sensors.
Right.
But we want to keep it simple. Right? Use managed services as much as possible.
Yeah, nobody wants to be managing servers if they don't have to.
Exactly.
So what's the best approach for this scenario? Well, we're going to use a combination of Amazon API Gateway and AWS Lambda functions.
API Gateway and Lambda. Okay.
Yep. API Gateway acts as that front door for your application.
Okay.
And it routes those incoming HTTP requests to the appropriate Lambda functions for processing.
So it's like a traffic cop directing those requests to the right destination.
Exactly.
Okay. And what do those Lambda functions do with the data?
So those Lambda functions process the data
Right.
and then store it in a database.
Got it. And what about the database itself? Which database service should the solutions architect use?
That's going to depend on the specific requirements. They could choose a fully managed serverless database like DynamoDB or Aurora Serverless, or if they need a specific database engine, they could deploy it on EC2 instances.
So it's a flexible architecture, and they can choose the database that best fits their needs.
Exactly.
I like it.
It's all about options, right?
Exactly. Okay, let's talk about real-time data analytics with question 67.
All right, real-time insights.
A bicycle sharing company is developing a multi-tier architecture to track the location of its bicycles during peak operating hours. The company wants to use these data points in its existing analytics platform. A solutions architect must determine the most viable multi-tier option to support this architecture. The data points must be accessible from a REST API. Which action meets these requirements for storing and retrieving location data? So imagine, those bike sharing programs you see in cities.
Yeah.
They've got all those bikes out there, and they want to track their location in real time.
Right?
So how do we build a system that can handle that kind of real-time data stream?
So we're going to use a combination of Amazon API Gateway and Amazon Kinesis Data Analytics.
API Gateway and Kinesis Data Analytics, okay.
Yep. So API Gateway acts as the entry point for those location updates from the bikes.
Okay.
Each bike sends its location data via HTTP requests to API Gateway.
So it's like a central hub for all those location pings.
Exactly.
Okay. And then where does the data go from there?
So API Gateway streams that data to Kinesis Data Analytics.
Okay.
And Kinesis Data Analytics processes it in real time.
Got it. So Kinesis Data Analytics is crunching those numbers and making sense of all that location data.
Exactly.
But how does the company actually access that processed data? How do they get it into their existing analytics platform?
Well, Kinesis Data Analytics can send that data to a bunch of different places.
Right.
It can send it to S3, it can send it to Redshift, or it can even send it directly to the company's analytics platform.
Awesome. So it's a real-time data pipeline from those bikes all the way to the company's analytics platform.
Yeah, real-time insights.
Okay, let's talk about centralized logging with question 68.
Okay, keeping those logs organized.
A company has multiple AWS accounts with applications deployed in the U.S. West Oregon region. Application logs are stored within Amazon S3 buckets in each account. The company wants to build a centralized log analysis solution that uses a single S3 bucket. Logs must not leave U.S. West Oregon, and the company wants to incur minimal operational overhead. Which solution meets these requirements in the most cost-effective way? All right, so centralized logging is super important.
Yeah, you want to be able to see what's going on across all your applications.
But how do we bring all those logs together without having to manually copy them around?
We can do that using S3 lifecycle policies.
Good.
Lifecycle policy is basically a set of rules that tells S3 what to do with objects in a bucket over time.
Okay.
So in this case, we can create a lifecycle policy that automatically copies those logs from the application buckets to a centralized S3 bucket.
Got it. So it's like an automated log courier.
Exactly.
Okay, but how do we make sure that those logs don't leave the U.S. West Oregon region?
So when you create that lifecycle policy, you specify the destination bucket for those copied objects.
Right.
And we make sure that that bucket is also in the U.S. West Oregon region.
Okay, so the logs stay put.
Yeah, they never leave the region.
All right, question 69 is about controlling access to sensitive information.
Okay, IAM policies, time to lock things down.
A company has hired a new cloud engineer who should not have access to an Amazon S3 bucket named Company Confidential. The cloud engineer must be able to read from and write to an S3 bucket called admin tools. Which IAM policy will meet these requirements? Policy document is given. So we need to craft an IAM policy that gives this cloud engineer the access they need, but also keeps them away from those confidential files.
Right. Least privilege again.
Least privilege, yep. So how do we translate that principle into a specific IAM policy?
Okay, so this policy is going to have two main parts.
Right.
An allow statement and a deny statement.
Okay.
So the allow statement gives the cloud engineer permission to read and write to the admin tools bucket. And the deny statement explicitly blocks any access to the company confidential bucket.
So it's like setting up a security checkpoint, right?
Yeah.
Some people are allowed through, others are not.
Exactly.
All right. Question 70 is about a massive data transformation project. 250 terabytes of data.
Wow, that's a lot of data.
A company currently has 250 TDTBs of backup files stored in Amazon S3 in a vendor's proprietary format using a Linux-based software application provided by the vendor. The company wants to retrieve files from Amazon S3, transform the files to an industry-standard format, and re-upload them to Amazon S3. The company wants to minimize the data transfer charges associated with this conversion. What should a solutions architect do to accomplish this? So we need to move and transform all that data without racking up a huge data transfer bill.
Right, data transfer costs can add up quickly.
What's the most cost-effective way to approach this?
So the key here is to minimize the amount of data movement, right? So the solutions architect should launch an EC2 instance in the same region as that S3 bucket.
Okay, so we're bringing the processing power to the data instead of the other way around.
Exactly.
Okay, so we launched that EC2 instance. What's next?
We installed the necessary conversion software on that instance.
Okay.
Remember, the company already has that Linux-based application.
Right.
So we just need to get it onto that EC2 instance.
Got it. So now that EC2 instance is our data conversion specialist.
Exactly.
What's the final step?
That EC2 instance retrieves the files from S3,
Okay.
performs the conversion, and then re-uploads those transformed files back to S3.
All within that same region?
Right. All within the same region to minimize those data transfer costs.
It's like a streamlined assembly line for data transformation.
Yeah, efficient and cost-effective.
Okay, on to question 71, saving money on those EC2 instances.
All right, who doesn't like saving money?
A solutions architect is designing a system to analyze the performance of financial markets while the markets are closed. The system will run a series of compute-intensive jobs for 4 hours every night. The time to complete the compute jobs is expected to remain constant. The jobs cannot be interrupted once started. Once completed, the system is expected to run for a minimum of 1 year. Which type of Amazon EC2 instance type should be used to reduce the cost of the system? So we've got these compute-intensive jobs that run on a predictable schedule, and we need this system to run for at least a year.
Right.
So how do we choose the most cost-effective EC2 instance type?
Scheduled reserved instances are going to be our best bet here.
Okay, scheduled reserved instances. I'm intrigued.
Yeah, so with a scheduled reserved instance, you're basically reserving EC2 capacity for a specific time period each day.
Okay.
So in this case, we'd reserve those instances for those 4 hours every night.
Right.
And since those jobs need to run for at least a year,
Yeah.
we can take advantage of those reserved instance discounts, which can save you a ton of money.
So it's like booking a hotel room in advance.
Exactly.
You get a much lower rate because you're committing to a specific time frame.
Right.
Okay, question 72 takes us back into the world of database performance.
Okay, let's optimize those queries.
An online shopping application accesses an Amazon RDS multi-AZ-DB instance. Database performance is slowing down the application after upgrading to the next generation instance type. There was no significant performance improvement. Analysis shows approximately 700 IOPS are sustained. Common queries run for long durations, and memory utilization is high. Which application change should the solutions architect recommend to solve these issues? So we've got a performance bottleneck, but throwing more powerful hardware at it isn't solving the problem.
Yeah, sometimes it's not about the hardware, it's about how you're using it.
Exactly. So what's the solution here? How do we speed things up?
Caching is going to be our secret weapon here.
Caching. Okay.
The solutions architect should recommend deploying a 2-node Amazon Elasticache cluster.
Elasticache. Okay.
Yep, so Elasticache is a high-performance in-memory caching service.
All right.
Think of it like a high-speed memory lane for your database.
Okay.
It stores frequently accessed data in memory.
Right.
So your application doesn't have to go all the way to the database every time it needs that information.
Got it. So for those frequently accessed items, Elasticache becomes the go-to source, bypassing the database altogether.
Exactly.
What happens if the data isn't in the cache, though? Does the application just grind to a halt?
Nope, the application can still query the database,
Okay.
and then the database will store a copy of that data in the cache for next time.
So it's like a self-learning cache.
Yeah, the more data is accessed, the more populated the cache becomes.
Okay, question 73 is about migrating those old-school file servers to the cloud.
All right, taking those file servers on a cloud adventure.
A company is migrating to the AWS cloud. A file server is the first workload to migrate. Users must be able to access the file share using the SMB protocol, which AWS Managed Service meets these requirements. So we need a cloud-based file server that can speak SMB, that familiar Windows file sharing protocol.
Right, we want to make that transition as seamless as possible for those users.
Exactly.
Well, Amazon FSx for Windows File Server is our go-to solution for this.
FSx for Windows File Server. Okay, I like the name.
Yeah, it does what it says on the tin.
So it's like a native Windows file server, but it's running in the AWS cloud.
Exactly.
What are some of the advantages of using FSx for Windows File Server?
So first off, it's fully managed.
Okay.
You don't have to worry about managing those servers.
Right.
AWS takes care of all that.
Okay.
It's also highly available and durable, so your files are always going to be accessible.
So it's like having a dedicated IT team managing your file servers, but without the overhead.
Exactly. Hands-free file server.
Okay. Question 74 takes us into the world of networking. Always a fun challenge.
Yeah, networking can be a bit tricky.
A company is using a VPC peering strategy to connect its VPCs in a single region to allow for cross-communication. A recent increase in account creations in VPCs has made it difficult to maintain the VPC peering strategy, and the company expects to grow to hundreds of VPCs. There are also new requests to create site-to-site VPNs with some of the VPCs. A solutions architect has been tasked with creating a centrally managed networking setup for multiple accounts, VPCs, and VPNs. What solution will meet these requirements? All right, so hundreds of VPCs, VPN connections. It sounds like a networking nightmare.
Yeah, it can get pretty complex.
So what's the AWS service that can bring order to this chaos?
We're going to call in the big guns for this one, AWS Transit Gateway.
Transit Gateway, okay.
Yep, so Transit Gateway is that central hub for connecting VPCs, on-premises networks, and VPN connections.
Okay, so it's like the grand central station of our AWS network.
Exactly.
And how does it make things easier for the solutions architect?
Well, with Transit Gateway, you can manage all those connections from a single location. You don't have to manage a bunch of individual peering connections.
Right.
It also provides features like routing, security, and monitoring.
So it's like a one-stop shop for managing your network.
Exactly.
Okay. Question 75 is about achieving high availability for both a production database and a reporting tool.
All right, high availability is always a good thing.
A company's production application runs online transaction processing, OLCP transactions, on an Amazon RDS MySQL DD instance. The company is launching a new reporting tool that will access the same data. The reporting tool must be highly available and not impact the performance of the production application. How can we achieve this? So we want to make sure that new reporting tool doesn't slow down those critical transactions.
Right, we want to keep those transactions flowing smoothly.
Exactly. So how do we achieve both high availability and performance isolation?
We can do that by creating a multi-AZ RDS read replica of that production database.
Okay, a read replica, so it's like a copy of the database that's just for reading.
Exactly, so it doesn't affect the performance of the production database.
Okay.
And because it's multi-AZ, it's highly available as well.
So if the primary database instance goes down, the read replica can take over.
Right, seamless failover.
Okay, question 76 takes us into the world of scaling strategies.
All right, scaling for success.
A company runs a 3-tier web application in a VPC across multiple AZs. Amazon EC2 instances run in auto-scaling groups for the application tier. The application needs an automated scaling plan that will analyze each resource's daily and weekly historical workload trends. The configuration must scale resources appropriately, according to both the forecast and the live changes in utilization. Which scaling strategy should a solutions architect recommend to meet these requirements? So we need a scaling strategy that's both proactive and reactive.
Right, we want to be prepared for those predictable traffic spikes,
Yeah.
but we also need to be able to adjust to those unexpected changes in demand. So what's the best strategy here? Well, we're going to use a combination of predictive scaling and dynamic scaling with target tracking.
Okay, predictive scaling and dynamic scaling.
Yeah, so predictive scaling uses machine learning to analyze those historical workload trends.
Okay.
And it forecasts future demand.
So it's like having a crystal ball that can predict those traffic spikes.
Exactly.
And what about dynamic scaling with target tracking?
So dynamic scaling adjusts your scaling capacity in real time based on those live changes in utilization.
Yeah.
It monitors those application performance metrics.
Right.
And it scales up or down to keep those metrics within a defined target range.
So it's like a self-adjusting thermostat for your application.
Exactly.
Okay, question 77 is about efficient image processing.
All right, let's optimize those pixels.
A company has an application that uses overnight digital images of products on store shelves to analyze inventory data. The application runs on Amazon EC2 instances behind an application load balancer and obtains the images from an Amazon S3 bucket for its metadata to be processed by worker nodes for analysis. A solutions architect needs to ensure that every image is processed by the worker nodes. What should the solutions architect do to meet these requirements in the most cost-effective way? So we've got all these images that need to be processed, and we want to make sure we're doing it efficiently and without breaking the bank.
Right. Image processing can be compute intensive.
So what's the winning formula here?
So we're going to combine the power of reserved instances with the flexibility of auto-scaling.
Okay, reserved instances and auto-scaling.
Yep. So we'll send that image metadata directly to EC2 reserved instances in an auto-scaling group with a dynamic scaling policy.
Okay, can you break that down for me a bit? Why are reserved instances a good fit for this scenario?
So reserved instances are a great way to save money on EC2 costs if you know you're going to need those instances for a while.
Right.
And since this image processing workload happens every night,
Yeah.
reserved instances are going to be the most cost-effective option.
Okay, and how does auto-scaling fit into this?
So auto-scaling will ensure that we always have enough worker nodes to handle the workload.
Right.
But it also means we're only paying for those instances when we need them.
So it's like having a workforce that can expand and contract as needed.
Exactly.
And that dynamic scaling policy you mentioned, what does that do?
So the dynamic scaling policy is what tells auto-scaling when to scale up or down.
Okay.
It uses Amazon CloudWatch to monitor the CPU utilization of those worker nodes.
Okay.
And it scales those instances up or down to keep that utilization within a healthy range.
So it's a self-adjusting system, making sure we have just the right amount of processing power.
Exactly. Efficient and cost-effective.
I like it. Okay, on to question 78, optimizing those image deliveries for a smooth user experience.
All right, making those images load lightning fast.
A company is designing a website that uses an Amazon S3 bucket to store static images. The company wants all future requests to have faster response times while reducing both latency and cost. Which service configuration should a solutions architect recommend?
So we want those images to load quickly. We want to minimize that annoying delay.
Right. Nobody likes waiting for images to load.
And we also want to keep those costs down.
Yep. Gotta love cost optimization.
So what's the AWS service that can deliver on all three fronts?
Amazon CloudFront to the rescue.
CloudFront, our old friend.
Yeah, it's like a global network of servers,
Right.
all ready to deliver your website content at lightning speed.
Okay, remind me how CloudFront actually works.
So CloudFront caches your content at those edge locations.
Okay.
So when someone requests an image,
Yeah.
CloudFront serves it up from the closest edge location.
Got it. So it's like having those images stored in warehouses all over the world.
Exactly.
So no matter where the user is.
They're getting those images from a nearby location.
Exactly. Which minimizes latency and improves those response times.
Okay, but how does CloudFront help with costs?
By caching those images at the edge locations, CloudFront reduces the number of requests that hit your origin S3 bucket,
Right.
which can save you a lot of money on data transfer costs.
So faster, lower latency, and cheaper.
The trifecta of website optimization.
All right, question 79 is about enforcing encryption for those sensitive files in S3.
Okay, time to lock down that data.
What should a solutions architect do to ensure that all objects uploaded to an Amazon S3 bucket are encrypted? So I want to make sure that every single object that lands in that S3 bucket is encrypted, no exceptions.
Right, encryption is non-negotiable.
Now, so what's the foolproof approach?
We can do that by updating the bucket policy to deny any put object requests that don't include a specific header.
Okay, a bucket policy, so a set of rules that govern what actions are allowed in the bucket.
Exactly. So we're going to deny any put object requests that don't have the XM's server-side encryption header set.
Okay, so the header basically tells S3 what type of encryption to use.
Exactly.
And by requiring that header in every request,
Right.
we're making sure that all objects are encrypted before they even hit the bucket.
Exactly. Encryption at the door.
Okay, question 80. is about handling a high-volume data stream from those internet-connected devices.
All right, the Internet of Things, sending all that data.
A company recently released a new type of internet-connected sensor. The company is expected to sell thousands of sensors, which are designed to stream high volumes of data each second to a central location. A solutions architect must design a solution that ingests and stores data so that engineering teams can analyze it in real time with millisecond responsiveness. Which solution should the solutions architect recommend? So we've got thousands of sensors all sending data constantly, and we need to be able to process it all in real time.
Right, we need a solution that can handle that kind of volume and speed.
Exactly. So what's the winning combination here?
Okay, so we're going to use Amazon Kinesis data streams to capture that data from those sensors.
Okay, so Kinesis Data Streams is our data ingestion specialist.
Exactly. All right.
And then we'll use AWS Lambda functions to process that data in real time.
So Lambda is like a bunch of little data processing robots all working in parallel.
Yeah, exactly.
Yeah.
And finally, we'll store all that data in Amazon DynamoDB.
So DynamoDB is our high-performance database that can handle those high-volume write operations.
Exactly.
Okay, so Kinesis data streams for ingestion, Lambda for processing, and DynamoDB for storage, a powerful combination for those real-time data challenges.
Yeah, real-time data dream team.
All right, let's talk about optimizing website performance for global users with question 81.
Okay, global reach without global infrastructure. A company serves a multilingual website with a fleet of EC2 instances behind an application load balancer. This architecture is currently running in the U.S. West Oregon region, but is exhibiting high latency for users located in other parts of the world. The website needs to serve requests quickly and efficiently regardless of the user's location. However, the company does not want to recreate the existing architecture across multiple regions. How should a solutions architect accomplish this? So we want to improve website performance for users all over the world,
Right.
but we don't want to have to deploy servers in every region.
Yeah, that can get expensive and complex.
Exactly. So what's the solution here?
CloudFront and some clever caching.
CloudFront and caching. Okay.
Yep, so we'll configure a CloudFront distribution with the application load balancer as the origin.
Okay.
But we're going to do something a little special with the caching.
What's that?
We're going to set the cache behavior settings to only cache based on the accept language request header.
Okay, so it's caching different versions of the website
Right.
based on the user's language preferences. So if someone's browser is set to French, CloudFront will serve them the French version of the website from a nearby location.
Right.
That's pretty cool.
It's like having a multilingual website, but without having to deploy servers all over the world.
Okay, question 82 is about choosing the right compute service for an API with variable request volume.
All right, serverless or serverful? That is the question.
A solutions architect is designing a new API using Amazon API Gateway that will receive requests from users. The volume of requests is highly variable. Several hours can pass without receiving a single request. The data processing will take place asynchronously, but should be completed within a few seconds after a request is made. Which compute service should the solutions architect have the API invoke to deliver the requirements at the lowest cost? So we've got an API that might be idle for hours at a time,
Right.
but when it does get requests, we need those requests to be processed quickly.
Yeah, and we want to do it all as cost effectively as possible.
Exactly. So what's the best compute service for this scenario?
This is a perfect use case for AWS Lambda.
Lambda, our serverless friend.
Yep, Lambda is ideal for those workloads with variable traffic patterns.
Okay, and how does Lambda help with cost optimization in this case?
So with Lambda, you only pay for what you use.
Right.
So if your API isn't receiving any requests, you're not paying anything.
So no more paying for those idle servers.
Exactly.
And can Lambda handle that asynchronous processing requirement?
Yeah, you can configure API Gateway to trigger a Lambda function asynchronously.
Okay.
So the function can process that request in the background.
While the API gateway returns an immediate response to the user.
Right, so the user doesn't have to wait around.
Our question 83 takes us into the world of high availability across multiple availability zones and regions.
Okay, high availability on a global scale.
A company is setting up an application to use an Amazon RDS MySQL DB instance. The database must be architected for high availability across AZs and AWS regions with minimal downtime. How should a solutions architect meet this requirement? So we need to make sure this database can withstand those availability zone and region failures.
Right, got to keep that data safe and accessible.
What's the recommended approach?
We're going to use a combination of techniques here.
Okay.
So first off, we'll set up an RDS MySQL multi-AZDB instance.
Okay, multi-AZ, so that creates a standby replica in a different availability zone.
Right. So if the primary database instance fails, that replica can take over seamlessly.
Okay, but what about protecting against an entire region failure?
We're also going to set up a read replica in a different region.
Okay.
That read replica is primarily for read operations, but if the entire region where your primary database is located goes offline, that read replica can be promoted to the new primary instance.
So it's like having a spare tire in your trunk just in case.
Exactly. You always want to be prepared.
Okay, question 84 is about securing those database credentials.
All right, keeping those passwords safe and sound.
A company hosts a multi-tier web application that uses an Amazon Aurora MySQL DB cluster for storage. The application tier is hosted on Amazon EC2 instances. The company's ID security guidelines mandate that the database credentials be encrypted and rotated every 14 days. What should a solutions architect do to meet the requirements with the least operational effort? So encrypted credentials, regular rotation, it sounds like a lot of manual work.
Yeah, you don't want to be doing that by hand.
So how do we automate this process and make it more secure?
Okay, so we're going to use AWS Systems Manager Parameter Store to store those credentials.
Okay, perimeter store, what's that?
So Parameter Store is a secure, centralized place to store configuration data, including passwords.
Right.
We're going to create parameters for the username and password, and we can encrypt those parameters using KMS.
Okay, so KMS is our key management service. That makes sense.
And then we'll use AWS Lambda to automatically rotate that password every 14 days.
So Lambda will generate a new password and update that parameter in Parameter Store. Okay, so the credentials are stored securely, they're rotated automatically. But how does the application actually access those credentials?
The application can retrieve those credentials from Parameter Store using the AWS SDK or the AWS CLI.
So it's like a self-service password portal.
Exactly.
Okay, question 85 takes us into the world of insurance codes.
All right, let's process some insurance claims.
A company is designing a web-based application running on AWS that processes insurance codes. Users will request quotes from the application. Quotes must be separated by code type, must be responded to within 24 hours, and must not be lost. The solution should be simple to set up and maintain. Which solution meets these requirements? So we need to process those insurance codes, make sure we respond to those requests in a timely manner, and we can't lose any data.
Right. Data integrity is key.
What's the solution here?
All right, so we're going to use a few different services here.
Okay.
First, we'll use Amazon Kinesis Data Firehose to ingest those insurance code requests.
Kinesis Data Firehose, okay.
Yep, and we'll use it to route those requests to different processing queues based on the code type.
So it's like a sorting machine for insurance codes.
Exactly.
Yeah.
Then we'll use Amazon Elasticsearch service to store and query that data.
Elasticsearch, okay.
Yep, it's great for searching and analyzing large data sets.
So Elasticsearch is our insurance code library.
Exactly.
Right.
And finally, we'll have a group of back-end application servers that will process those requests and generate those quotes.
So those application servers are like our insurance agents.
Exactly.
All right, so the Kinesis Data Firehose sorts those requests, Elasticsearch stores, and indexes them.
Yeah.
And those application servers process them and generate those quotes.
Right. A well-oiled machine for processing insurance codes.
Okay, question 86 is about building a multi-layered security architecture.
Okay, time to fortify our defenses.
A solutions architect at a company is designing the architecture for a two-tiered web application. The web application is composed of an internet-facing application load balancer that forwards traffic to an Amazon auto-scaling group of Amazon EC2 instances. The EC2 instances must be able to access a database that runs on Amazon RDS. The company has concocted a defense-in-depth approach to the network layout. The company does not want to rely solely on security groups or network ACLs. Only the minimum resources that are necessary should be routable from the internet. Which network design should the solutions architect recommend to meet these requirements? So we need to protect this web application from those internet bad guys, and we want to use a defense-in-depth approach.
Right, layers of security.
What's the best way to design this network?
So we're going to put that application load balancer in a public subnet.
Okay.
And then those EC2 instances and that RDS database in private subnets.
Okay, public and private subnets. Can you remind me what those are?
Yeah, so a public subnet is directly accessible from the internet.
Okay.
A private subnet is not. So by putting those sensitive resources in a private subnet, we're making it much harder for those attackers to reach them.
Okay, so the application load balancer is our public-facing entry point.
Right.
But the application servers and the database are tucked away in a private subnet.
Exactly.
But how do those EC2 instances talk to the RDS database if it's in a private subnet?
So communication between those private subnets can happen through security groups and routing rules.
Okay, so we can control the flow of traffic between those different tiers.
Exactly.
Okay, question 87 is about optimizing database performance for a massive table.
All right, let's make those queries run faster.
A company maintains a searchable repository of items on its website. Data is stored in an Amazon RDS from MySQL database table that contains over 10 million rows. The database has 2 TB of SSD storage. There are millions of updates against this data every day. Through the company website, the company has noticed some operations are taking 10 seconds or longer and has determined the storage performance is the bottleneck. What is the solution? So we've got this huge database table, lots of updates, and some queries are taking way too long.
Right, sounds like a performance bottleneck.
So what's the solution here? How do we give this database a performance boost?
We need to upgrade to a more powerful storage type, provisioned IOPS SSD.
Okay, provisioned IOPS SSD.
Yep, so provisioned IOPS SD gives you more control over those IOPS.
Right, IOPS, input-output operations per second, the speed of those read and write operations.
Exactly.
Okay, but what about all their existing data? Do we need to migrate it to the new storage type?
Nope. You can modify the storage type of an RDS instance without having to migrate the data.
Oh, that's convenient.
Yeah, RDS handles all that for you.
All right, on to question 88, achieving high availability for a mission-critical application.
Okay, got to keep those credit card payments flowing.
A company runs a 3-tier web application to process credit card payments. The front-end user interface consists of static web pages. The application tier can have long-running processes. The database tier uses MySQL. The application is currently running on a single general-purpose large Amazon EC2 instance. The solutions architect needs to decouple the service to make the web application highly available. Which solution would provide the highest availability? So we've got this monolithic application running on a single EC2 instance.
Right.
And we need to make it more resilient, more highly available.
Yeah, we don't want a single point of failure.
So how do we break this application down and optimize each tier for high availability?
All right, so first, those static web pages,
Yeah.
those are perfect for Amazon CloudFront.
Okay, so we're moving those static assets to CloudFront
Right.
to improve performance and availability.
Exactly.
What about the application tier with those long-running processes?
So we'll keep the application tier on EC2.
All right.
But we're going to put those instances in an auto-scaling group across multiple availability zones.
Okay, so auto-scaling will keep those instances running even if one availability zone goes down.
Exactly.
And it'll automatically scale those instances up or down based on demand.
Right, so we're covered for both availability and scalability.
What about the database tier?
So for the database tier, we'll move it to Amazon RDS and deploy it in a multi-AZ configuration.
Okay, so RDS for the managed database service, multi-AZ for high availability.
Right.
By decoupling those services and optimizing each tier for high availability,
Yeah.
we've transformed this monolithic application into a much more resilient system.
Exactly.
Okay, let's talk about improving application availability with question 89. A company's HTTP application is behind a network load balancer. The network load balancer target group is configured to use an Amazon EC2 auto scaling group with multiple EC2 instances that run the web service. The company notices that the NLB is not detecting HTTP errors for the application. These errors require a manual restart of the EC2 instances that run the web services. The company needs to improve the application availability without writing custom scripts or code. What should the solutions architect do?
So we've got a network load balancer, but it's not detecting those HTTP errors.
Right, so those errors are slipping through the cracks.
And that's leading to manual restarts, which we want to avoid.
Yeah, manual anything is usually not a good sign.
So what's the solution here?
We're going to replace that network load balancer with an application load balancer.
Okay, swapping out the load balancer.
Yep, an application load balancer is better suited for this scenario.
Why is that?
Okay, so a network load balancer, it operates at the network layer.
Okay.
It's just concerned with TCP traffic.
Right. An application load balancer, it operates at the application layer.
Okay.
So it can actually understand HTTP traffic.
So it can detect those HTTP errors.
Exactly.
Okay, and once the application load balancer detects an unhealthy instance,
Yeah.
It automatically stops sending traffic to that instance.
Right. So users don't experience those errors.
But we still need to address those manual restarts.
Yeah. So we're going to enable those HTTP health checks on the application load balancer.
Okay.
We give the application load balancer the URL of our application so it
Yeah.
knows what to check.
Okay.
And then we configure the application load balancer to trigger an auto-scaling action to replace those unhealthy instances automatically.
So the application load balancer detects an HTTP error.
Yeah.
Takes that instance out of service,
Right.
and auto-scaling spins up a new healthy instance.
Exactly. A self-healing system.
I like it. All right, on to question 90, simplifying connectivity for those private database servers.
Okay. Ditching those NAT instances.
A company runs an application in the AWS cloud and uses Amazon DynamoDB as the database. The company deploys Amazon EC2 instances to a private network to process data from the database. The company uses 2 NAT instances to provide connectivity to DynamoDB. The company wants to retire the NAT instances. The solutions architect must implement a solution that provides connectivity to DynamoDB and that does not require ongoing management. Was the most cost-effective solution. So we've got these database servers in a private subnet,
Right.
and they need to talk to DynamoDB, but we don't want to manage those NAT instances anymore.
Yeah. Managing servers. So last decade.
Exactly. So what's the solution here?
A managed NAT gateway is the way to go.
Okay, a managed NAT gateway.
Yep. So it provides that connectivity between your private subnet and DynamoDB,
Right.
but you don't have to manage the underlying servers.
So it's a set it and forget it solution.
Exactly.
Okay, question 91 is about finding the most cost-effective storage solution to those infrequently accessed files.
All right. Time to optimize those storage costs.
A company wants to move its on-premises network attached storage to AWS. The company wants to make the data available to any Linux instances within its VPC and ensure changes are automatically synchronized across all instances accessing the data store. The majority of data is accessed very rarely, and some files are accessed by multiple users at the same time. Which solution is the most cost-effective? So we need a cloud-based NAS solution that can handle shared access, infrequent access, and keep those costs down.
Right. Gotta love those cost savings.
Exactly. So what's the AWS service that fits the bill?
Amazon Elastic File System, or EFS, is perfect for this.
Okay, EFS, our shared file system friend.
Yep. So EFS can be accessed by multiple EC2 instances at the same time.
Right.
And it automatically scales up or down based on your needs.
Okay, and you only pay for what you use, which is great for those infrequently accessed files.
Exactly.
But how do we specifically address that infrequent access requirement?
We can set up a lifecycle policy
Okay.
that automatically moves those infrequently accessed files to EFS infrequent access, or EFSIA.
Okay, so EFSIA is a lower-cost storage class for those less frequently accessed files.
Right. It's like having an archive tier within EFS.
Okay, on to question 92, securing those serverless workloads.
All right. Serverless security, always important.
A company is preparing to deploy a new serverless workload. A solutions architect needs to configure permissions for invoking an AWS Lambda function. The function will be triggered by an Amazon Event Bridge rule. Permissions should be configured using the principle of least privilege. Which solution will meet these requirements? So we need to make sure that only authorized services can trigger this Lambda function.
Right. Got to lock down those permissions.
So what's the best way to do that?
We're going to add a resource-based policy to that Lambda function.
Okay, a resource-based policy, and what will that policy say?
So the policy will have Lambda invoke function as the action.
Okay, so that's the permission we're granting.
Right.
And the principal will be events.amazonos.com.
Exactly. So we're giving EventBridge permission to invoke the function.
But nothing else has that permission.
Right. Least privilege in action.
All right, question 93 is about protecting sensitive data before it even reaches the cloud.
Okay. Encrypting that data at the source.
A company plans to store sensitive user data on Amazon S3. Internal security compliance requirements mandate encryption of data before sending it to Amazon S3. Which solution should the solutions architect recommend to satisfy this requirement? So we need to encrypt the data before it's uploaded to S3.
Right. So even if someone intercepts the data in transit, they won't be able to read it.
Exactly. So what's the recommended approach here?
Client-side encryption with a master key stored in AWS KMS.
Okay, client-side encryption, so the data is encrypted on the user's device before it's even sent to S3.
Exactly.
And KMS is our key management service.
Right. It's a secure place to store your encryption keys.
So we're encrypting the data at the source and managing those keys securely.
Yeah, multi-layered security.
Okay, let's tackle a connectivity challenge for those database servers in a private subnet with question 94.
All right. Connectivity without compromise.
A company recently deployed a two-tier application in 2 AZs in the U.S. East and Virginia region. The database is deployed in a private subnet, while the web servers are deployed in a public subnet. An internet gateway is attached to the VPC. The application and database run on Amazon EC2 instances. The database servers are unable to access patches on the internet. A solutions architect needs to design a solution that maintains database security with the least operational overhead. Which solution meets these requirements? So we need to give those database servers internet access for patches.
Right.
But we don't want to expose them to the internet.
Yeah, security is paramount.
What's the recommended approach?
So we're going to deploy a NAT gateway in the public subnet of each availability zone.
Okay, a NAT gateway.
Yep, and we'll associate it with an elastic IP address.
Right, so that NAT gateway has a static IP address.
Exactly.
Okay, and then what?
Then we update the routing table of the private subnet to use the NAT gateway as the default route.
So all traffic from those database servers that's destined for the internet will go through the NAT gateway.
Exactly.
Okay, on to question 95. Creating a tiered storage solution for backups.
All right, backups, gotta have them.
The company is backing up on-premises databases to local file server shares using the SMB protocol. The company requires immediate access to 1 week of backup files to meet recovery objectives. Recovery after a week is less likely to occur, and the company can tolerate a delay in accessing older backup files. What should a solutions architect do to meet these requirements with the least operational effort?
So we need to store those backups in a way that balances performance and cost.
Right, we need different tiers for different types of backups.
What's the recommended approach?
Okay, so for those recent backups, we'll use Amazon FSx for Windows File Server.
Okay, FSx for Windows File Server, that makes sense.
Yep, it's compatible with SMB.
Right, so it's a seamless transition from those on-premises file servers.
Exactly.
And for those older backups.
They'll use AWS Storage Gateway.
Okay, storage gateway. Can you remind me what that is?
Yeah, so Storage Gateway acts as a bridge between your on-premises environment and the AWS cloud. In this case, we'll use the file gateway configuration,
right,
which stores those backups as objects in Amazon S3.
Okay, so S3 for those long-term, less frequently accessed backups.
Right.
But how do we integrate FSx for Windows File Server and S3 into a seamless solution?
We can configure Storage Gateway to use FSx for Windows File Server as a cache.
Okay, so when an application requests an older backup file, Storage Gateway will check the cache on FSx first.
Right.
And if it's not there, it'll retrieve it from S3.
Exactly, a two-tiered system with intelligent caching.
I like it. Okay, question 96 is about securing those internet-facing databases.
I got to keep those databases safe. A company is designing a web-based application running on Amazon EC2 for Linux-based instances that store sensitive user data in Amazon RDS MySQL multi-AZDB instances. The EC2 instances are in public subnets, and the RDS DB instances are in private subnets. The security team has mandated that the DB instances be secured against web-based attacks. What should a solutions architect recommend? Sensitive user data, internet-facing application, we need to make sure those databases are locked down tight.
Right. Security is job number one.
So what's the recommended approach?
Okay, so first off, we're going to make sure those EC2 instances are in an auto-scaling group behind an application load balancer.
Okay, so high availability and scalability.
Exactly.
What else?
We're going to deploy AWS WAF.
Okay, WES, our web application firewall?
Yep, it'll monitor that inbound web traffic for any suspicious activity.
So it's like a security guard for our application.
Exactly. And then we'll also implement security groups for both the web application servers and the database instances.
Okay, so security groups to control traffic between those different tiers. How do we configure those security groups to maximize protection?
So we configure the RDS security group to only allow traffic from the web application server security group.
Okay.
And only on port 3306, which is the default port for MySQL.
So we're creating a secure tunnel between the application servers and the database servers.
Exactly. No unauthorized access.
Okay, question 97 is about choosing the right storage solution for those containerized workloads.
Right. Containers need storage too.
A solutions architect is designing a solution that involves orchestrating a series of Amazon Elastic Container Service, ECS task types, running on Amazon EC2 instances that are part of an ECS cluster. The output and state data for all tasks need to be stored. The amount of data output by each task is approximately 10 millibit, and there could be hundreds of tasks running at a time. The system should be optimized for high-frequency reading and writing, as all outputs are archived and deleted. The storage size is not expected to exceed 1 TB. What is the best storage solution? So we've got these ECS tasks, they're generating data, and we need a storage solution that can handle those high-frequency read and write operations.
Right. And we don't want to break the bank on storage costs.
So what's the best option here?
Amazon EFS with bursting throughput mode is going to be our winner.
Okay, EFS, we've seen that before.
Yeah, it's our shared file system friend.
And why bursting throughput mode?
So bursting throughput mode allows your file system to handle those sudden spikes in traffic
Okay.
without having to provision for the highest level of throughput all the time.
So it's like having a car with a turbocharger. It kicks in when you need that extra boost.
Exactly.
All right, let's wrap things up with question 98. A storage solution for a truly massive amount of data, 900 terabytes.
Wow, that's a lot of text documents.
A company is building a web-based application running on Amazon EC2 instances in multiple AZs. The web application will provide access to a repository of text documents totaling about 900 TB in size. The company anticipates that the web application will experience periods of high demand. The solutions architect must ensure that the storage component for the text documents can scale to meet the demands of the application at all times. The company is concerned about the overall cost of the solution. Which storage solution meets these requirements most cost-effectively? So we need a storage solution that can scale, handle high demand, and keep those costs down.
Right. The holy trinity of storage requirements.
What's the AWS service that can deliver on all three fronts?
Amazon S3.
S3, our simple storage service friend.
Yep, S3 is designed to handle massive amounts of data. And it can scale on demand to handle any traffic you throw at it.
So even with 900 terabytes of data and unpredictable traffic spikes, S3 can handle it.
No problem.
And with multiple storage classes to choose from, we can optimize those costs.
Exactly. S3 gives you the flexibility to choose the right storage class for your data.
Wow, we've covered a lot of ground today.
We have.
From optimizing databases to securing applications and choosing the right storage solutions for all sorts of scenarios.
A whirlwind tour of AWS services.
Exactly. And you know what? I'm feeling pretty confident about those AWS exams now.
Me too. I think we're ready to ace them.
All right, folks, that's it for this deep dive.
Until next time.
Happy learning.